So what happens when the cloud, the very thing our entire digital world is built on, just stops working? Look, it's not a question of if it's going to happen, but when. And when a giant like Microsoft Azure takes a hit, you feel the shock waves everywhere. In this explainer, we're going to pull back the curtain on what went wrong inside Azure and lay out the exact playbook they use, and you can too, to build systems that are truly unbreakable. And yeah, this pretty much sums it up, right? It's that raw, chaotic feeling, that sinking in your stomach that IT pros everywhere know all too well when every dashboard turns red and the alerts just won't stop. It literally feels like the entire internet is on fire. And the scale of these failures, it is absolutely staggering. A recent similar outage from a company called CrowdStrike took down a mind-boggling 8.5 million machines. I mean, think about that blast radius. We're talking millions of users, critical services, all grinding to a dead halt. It's a massive reminder of just how connected and honestly, how fragile our systems really are. Welcome to the AgileWoW podcast, your trusted partner in Agile, Scrum, artificial intelligence training, coaching, and innovation. AgileWoW is on a mission to build communities, empower professionals, and accelerate the learning curve one conversation at a time. Visit our website, www.agilewow.com, for more details. All right, so let's start digging in. We're going to deconstruct what happens when a tech titan like Microsoft has a really, really bad day. We'll use their recent Azure outages as a case study to get to the bottom of the vulnerabilities hidden deep inside the infrastructure we all rely on. So, over the last year or so, a whole series of major outages slammed into Azure. We're talking services like Microsoft 365, Outlook, even Xbox Live. They just went dark for hours. And these weren't just little glitches. No, these were cascading failures that showed some serious weaknesses and taught the entire industry some very painful, very public lessons. So, what actually caused all this chaos? See, if you want to build a system that doesn't break, you first have to understand all the ways it can break. And usually it boils down to two main culprits. Okay, so in one corner, you've got the external attack. Think of a DDoS attack, right? Malicious actors basically send a fire hose of traffic at your front door so that none of your actual users can get in. And in the other corner, you have the internal error, which is often just a simple human mistake. An engineer pushes a bad line of code, a wrong configuration, and it just creates this domino effect. One is malicious, the other is an accident, but the end result is exactly the same: downtime. Now, this is where it gets really wild. In one of the Azure incidents, a huge DDoS attack was actually made worse because the very system that was supposed to protect against it had a bug. So instead of being a shield, it malfunctioned and basically amplified the damage. But here's a thought. What if the real enemy isn't an attack from the outside or a clumsy mistake on the inside? What if it's something your own system is literally designed to ignore? And that brings us to this much sneakier threat. It's like a silent killer that your traditional monitoring dashboards will just completely miss. This is the exact kind of problem that keeps cloud engineers tossing and turning at night. So how do you fight an enemy you can't even see? Well, this hidden threat has a name. It's called gray failure. It's not a simple on or off, working or broken kind of thing. Instead, a component in your system is just sick. It's limping along, causing terrible performance, randomly dropping data. It's not totally dead, but it's definitely not healthy, which makes it incredibly hard to spot. And this question right here gets to the heart of this weird paradox. I mean, how is it possible? Your system's own health checks are all coming back green. Everything looks fine, but your users are absolutely furious because for them, the experience is slow and buggy. How can that be? Well, the answer is a tricky concept called differential observability. It's a huge, dangerous blind spot. Your internal monitors are all green, but your users are seeing red. Why? Because the system's internal health checks aren't experiencing what the user is. The system looks in the mirror and says, hey, I'm perfectly fine, while your user on the outside is screaming, dude, you are on fire. That's the core of gray failure. So how do you fix a problem your system won't even admit it has? We're going to come back and close that loop. But first, let's build the foundation of our solution. Okay, let's get into the solution. Because just hoping for the best, that's not a strategy. A real strategy is a well-rehearsed plan built on really clear principles. And hey, if you're getting some value out of this playbook so far, do me a favor and hit that like button. It really helps us out. Now, let's start with the groundwork. So, the very first step in any resilience playbook is to define your recovery objectives. RTO, or recovery time objective, is how fast you need to get back up. RPO, recovery point objective, is how much data you can stand to lose. Now, you can't protect every single application like it's the crown jewels. That would be way too expensive. So you have to put them in tiers. Tier 0, that's your mission-critical stuff that absolutely can't be down for more than 5 minutes. But Tier 4, that might be some internal tool that, could be down for a week. This tiering is what's going to dictate your entire strategy. And those RTO and RPO decisions you just made? They lead to 2 fundamental ways of building your system. On the left, you have active/passive. Think of it like having a spare tire. One region is live, and a second one is in the trunk, ready to go. It's cheaper, but recovery is slower. On the right, you've got active/active. Your application is live in multiple places at the same time. It's way more expensive and complex, but it gives you almost zero downtime. For those Tier 0 apps we talked about, you're probably going to be investing in an active/active model. Okay, let's talk tactics. Picture this. You're in the middle of a big deployment, and suddenly things start going wrong. You've basically got 2 main choices. A rollback is where you try to undo the change on the systems that are already running. A fallback, on the other hand, is much cleaner. You just shift all the traffic back to the old stable version that you smartly kept running in the background. Having a clear practice plan for this exact moment is absolutely non-negotiable. So if we boil down all the lessons from these huge outages, we get these 5 essential takeaways. 1. Don't put all your eggs in one cloud provider's basket. 2. Use AI to actually get better at spotting threats. 3. Constantly monitor your systems and train your people. 4. Have a plan that you've actually practiced. And 5. The basics still matter, like layers security and multi-factor authentication. These are really the core pillars for any modern resilient system. Just a quick reminder, this episode is brought to you by AgileWoW. If you're looking to level up your skills, check out our upcoming workshops on product management, agile leadership, and artificial intelligence. These are the concepts that will define the next decade of tech leadership. Visit our website, www.agilewow.com, for more details. All right, let's bring it all home. We've got our playbook, we understand what usually goes wrong, but now it's time to finally close the loop on that hidden threat we talked about earlier. It's time to stop just reacting to failure and start proactively making our systems unbreakable. So let's circle all the way back to gray failure and that differential observability problem. You can have the absolute best, most expensive, multi-region automated fallback plan in the world, but it is completely and totally useless if your system doesn't even know that it's failing. Your playbook is only as good as your ability to detect a problem in the first place. So how do we fix this? Here's the 3-step strategy to close that observability gap. First, you need automated smoke tests that act like real users, constantly checking your system from the outside in. Second, you need telemetry that's correlated, so when a user reports a problem, you can instantly trace it back to the exact cause. And third, you need a clear, practiced escalation path so that when a problem is finally spotted, it gets to the right engineering team immediately. This is how you defeat gray failure. And this really gets to the ultimate lesson here. True resilience, it isn't some product you can just go buy or a switch you can flip. It's an ongoing process. It has to be baked into your architecture from day one. It has to be proven through constant testing, and it has to get better by learning from every single failure, big or small. Ultimately, this is what it all comes down to. The cloud will fail. An Azure outage, an AWS outage, a simple configuration error, something is going to happen. And preparing for that failure isn't being pessimistic. It's the absolute foundation of a robust, modern, and successful engineering culture. So the only real question is, are you ready? Thanks for tuning in to the AgileWoW podcast, supported by AgileWoW. If you enjoyed this episode, make sure to follow the podcast, leave us a review, and share it with your team. And if you want to advance your Agile journey, check out AgileWoW's upcoming trainings, events, and workshops, all designed to help you grow faster, smarter, and together. Until next time, stay agile, stay curious.